It is the last section of Cal 1. All right, so we're going to just touch on hyperbolic trig. And I mean barely touch. So if you'll remember, unit circle trig is you have a circle that has a unit, 1 unit length for a radius. Hyperbolic trig is based on the fact that you have hyperbolas instead. Okay, so you end up making triangles this way that go out, blah, 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 blah. So you can look up what hyperbolic trig is. And then the way we note it is we put H's on the end of everything. So you have sine or sine H for hyperbolic trig, which we literally pronounce as cinch. Okay, I know it sounds stupid. And then we have cosine, which in hyperbolic would be cosh. And then we have tangent, which in hyperbolic is tanch. And then cosec and sech and cotanch, which looks like cough but is not. All right, and so all we're going to do literally is first of all figure out how to play with it. They are not really used that often in the lower math courses, and so you have to dig for it on your calculator. So if you hit the second button and then 0, it'll take you to your catalog, and it immediately puts you in alpha mode. So if you just type the letter of the thing that you want, so for instance, the first thing I want to do is I want to evaluate the cinch of 7. So I want S's. So if you'll notice, the natural log also has an S on it. So just hit the natural log key, and it will take you to where the S's start. So you just have to kind of sort of scroll on down until you see cinch. So S-I-N, almost there. All right, so right there. So hang on. I wish you could see this somewhat better. Look, there it is. Okay, hang on. See it? See it? All right, so as soon as you hit enter, make sure you're in radians. Make sure you're in radians. Yes, I'm in radians. All right, so I want the cinch of 7. So hit that, I get 548.32. Okay, and that is your answer. So 548.32, I want 3 decimal places. So 548.316. And now I want the tanch of -2. So do second 0 to take you to the catalog. And then I want the things that start with T. So if you'll notice on the 4, there's a little T right next to it. So hit 4, and then this one is easier to find. It's only the 4th one down, and there's the tanch of -2. So I get -9640, or sorry, to 3 decimal places. There you go. So -964, 0.964, okay? Now we're just going to find the derivative. So this is seriously the easiest section of the whole thing. All right, so if I want to come up here, it says if I'm taking the derivative of cinch, then the derivative is cosh, u du. So this says, what's the derivative of cinch? The derivative is cosh times the derivative of the inside. So you're still doing chain rule, okay? And that's your answer, okay? Be careful, because a lot of them are similar, but a lot of them aren't, okay? So I want the tanch. Well, the derivative of tangent is secant squared. So looky here. The derivative of tanch is sech squared, okay? So I have sech squared of 8x squared minus 3 times the derivative of the inside, which is 16x. And you're done, okay? So find the derivative of the function. I'm going to take the derivative of a natural log. So how do I take the derivative of a natural log? I take the derivative of the argument, which we found out a while ago was cosh, over the argument itself, which is cinch. And by the way, that is cosh. Okay? So you can just leave it like that if you want to. All right, so find the derivative. I'm going to have to do product rule. So I've got the first, which is x squared plus 3, times the derivative of the second. So the derivative of cough is negative sech squared. Okay? So I've got negative I said sec squared, and I meant cosec squared. Sorry. All right, so cosec squared of what's sitting there times the derivative of the inside, which is 1/5. So I've got first times the derivative of the second. I just put the negative out front. Plus the second, which is x over 5, times the derivative of the first, which is 2x. And you're done. Okay. So we got a couple more. I have an e to the. So find the equation of the tangent line. So if I'm dealing with tangent lines, that means you need to take derivatives. So I have an e to the. How do I take the derivative of an e to the? So the derivative of an e to the sinh is going to be, I write what's sitting there, times the derivative of my exponent, which is cosh x. So this is the formula for slope. Well, I'm dealing with the point 0, 1. So I need to evaluate this stuff at 0. Okay. So I'm going to find the cosh first. So do second catalog. And then C is going to be the program button. And scroll on down till you find cosh. Hang on, still looking. All right, so the cosh of 0 is going to be 1. And then I have e to the. So times e to the, and then I have sinh. So you know what? I'm just going to cheat, and I'm going to come back up here and just use that one so I don't have to keep digging for it. But I'm evaluating it at 0. Okay? So that gives me an answer of 1. So my slope is 1. So they've given you the y-intercept, and your slope is 1. So the equation of the tangent line is 1x plus 0. Sorry, good heavens, plus 1. My land of Goshen. All right, I'm going to do 7 last, just because I want to finish up the weird stuff first. All right, so if I'm integrating cosh, okay, so my u is going to be 3x, which means my du is 3 dx. So I need a 3 balanced with a third. And then the integral will be 1/3 sinh of 3x plus c. And again, you'll notice down here on your sheet, you don't have any hyperbolic trig functions, but you do up here. So if you're integrating cosh, what are you going to get back? You're going to get sinh, okay? And then this one says, I would like to integrate sinh. So now before, in unit circle trig, the integral of sine is negative cosine. So be careful, because the integral of sinh is positive cosh, okay? So just watch out for those things. What's my u? My u is 9 minus 8x dx. And so my du is a negative 8. So I need a negative 8, so balance with a negative 1/8. And now my integral will be negative 1/8 of cosh 9 minus 8x plus c. Okay, so let's get back to this one. This one is a complete and total calculator problem right here. So a model for a power cable suspended between 2 towers is given. So the model is 2 plus 16 cosh of x over 16. And the width of this thing goes from negative 16 to positive 16. Okay, so all three of the, well, first, that's not a good power cable. Otherwise, people are dying, okay? We just figured out that if the cosh of 0 is 1, on this one up here, okay? So the cosh of 0, if I shove in a 0, I'm going to get the cosh of 0 is 1, times 16 is 16, plus 2 is 18. So I know that this thing should hit at 18. And so I'm just telling you right now it's going to be this one, okay? So there's your power line, and it just kind of sags because of gravity. And so from here, I want to know the heights of the cable at the towers, as well as at the midpoint. So I want to know the height at negative 16, or I want to know the position, which is your original function, at negative 16, and I got that from here. And again at positive 16, and then again at 0, okay? So if you haven't gotten that yet, then what we need to do is go to y equals if you have not figured out your graph yet. So I'm going to hit cosh, hang on, catalog, and I need C, and I'm going to find the cosh of, hang on, it takes so long. All right, So I have the cosh of, and I forgot, hang on, 2 plus 16. Dadgummit, I just typed over it. I'm so sorry. All right. I thought it was going to scooch it ahead. So we have the cosh of, cosh. All right. So 2 plus 16, cosh of x over 16. Okay. So that's what I've got. Now, I wish I had a great way to show this to you, but I keep having to fight with it. Ooh, look at that. All right. So here I go. So when it graphs, you will see that I should have changed my window first. All right, so I'm going to change my window, and the way I'm going to do that, because right now I'm at a -10 to a +10, so I'm way off the grid. So hit zoom, and then choose zoom out, which is number 3, and it's going to center it, and just hit enter, and it's going to zoom out now. Okay, so this is going to give me, look, my pretty picture. Do you see the pretty picture? Okay, so if I want to know the value of these things, what I can do is hit second calc, and I want to know the value. So choose 1, and then, well, what's your value at a -16? So if x is -16, what height do you get? So all I did was second calc and option 1. So I get a height of 26.689. So 26.689. Now this thing is symmetric, which means you should know what the height is over here now. It's also going to be 26.689. But just in case you don't trust me, do second calc, choose the value, and do +16, and then you will see it is 26.689. Okay, so let's verify that the value at the midpoint, which is 0, is actually 18, which it is. Okay, so now I found those things just using my calculator, so I didn't actually have to go in and evaluate anything. So I know that the height at the towers is 26.689, and I know that the height at the midpoint is 18 feet. So this one says find the slope of the model at the point where the cable meets the right-hand tower. So what I could do is I could take the derivative of 2 plus 16 times the cosh of x over 16, and that thing's derivative, that goes to 0. The derivative of cosh is sinh, and then x over 16 times the derivative of the inside would be 1/16. So the 16 and the 1/16 would reduce. So this is the formula. And then what you would do is you would sub in a 16. So why? Because I want the right-hand tower. So the right-hand tower is at 16 feet. Okay. So when I evaluate that, I'll get sinh of 16 over 16, which is the sinh of 1. Now, if you want to do all that, or look at this magic, hit second calc and choose 6, which says dy dx. And it says, where do you want the derivative to be evaluated at? And so I am going to hit +16, and it's going to think for a second, and it's going to say your derivative is 1.175. Okay, your derivative is 1.175. So if I were to go to my home screen, and if I find the sinh of 1, I'm going to get 1.175. Okay, so either way. But this whole problem can be done in your calculator, and my friends, that is the end of Calculus 1. Be a happy clam.